Okay, so this is number 39 on chapter 3. A radar station locates a sinking ship at range 17.3 kilometers and bearing 136 degrees clockwise from north. From the same station, a rescue plane is at horizontal range 19.6 kilometers, 153 degrees clockwise from north, with elevation 2.2 kilometers. Part A, write the position vector for the ship relative to the plane letting I hat represent east, j hat north, and k hat up. And part B, how far apart are the plane and the ship? So for part A, we're going to have to draw the position vectors for both the plane and the ship. We'll do the ship first because it doesn't have a K component, which makes it easier to draw. So if we have a coordinate plane, the ship is at range 17.3 kilometers and bearing 136 degrees clockwise from north. So it'll be somewhere here, and we can call this vector A. And so the magnitude will be 17.3 kilometers. And this angle will be 46 degrees because 90 plus 46 is 136 degrees. So if we write vector A in a component form, we'll get 17.3 cosine 46 degrees I hat minus 17.3 sine 46 degrees j hat plus 0 k hat because this is there is no elevation for the ship. For the plane, we'll still draw it in 2 dimensions because since we're given that the elevation is 2.2, we know that the k component is going to be 2.2, and the k component doesn't affect I hat or j hat because when we do vector problems, we separate the components. So for the ship, it has horizontal range 19.6 kilometers, 153 degrees clockwise from north. So it'll be somewhere here. We can call this vector B. Has magnitude 19.6 kilometers. And this angle will be 63 degrees because 90 plus 63 is 153 degrees. So for the plane, we have vector B equals 19.6 cosine 63 degrees I minus 19.6 sine 63 degrees j hat plus 2.2 k hat because again the elevation is 2.2 kilometers. So part A wants the position vector of the ship relative to the plane. So it'll be the vector, we'll call it R, from the plane to the ship because it's in relation to the plane, so the plane is basically the origin. So when you have a vector that has an initial point and a terminal point, to find that resultant vector, you subtract the initial point from the terminal point. So in this case, we'll be doing the ship components minus the plane components because the ship is the terminal point and the plane is the initial. So we have 17.3 cosine 46 degrees minus 19.6 cosine 63 degrees I hat plus negative 17.3 sine 46 degrees minus negative 19. So plus 19.6 sine 63 degrees j hat plus 0 minus 2.2 k hat. So if we simplify this, we'll get that this position vector is 3.12 I hat plus 5.02 j hat minus 2.2 k hat. So this is the answer to part A. Moving on to part B, how far apart are the plane and the ship? So this is simply the magnitude of this vector, and that is just the Pythagorean theorem. But since there's 3 components, we just square all 3 components and then take the square root of that sum. So we'll have 3.12 squared plus 5.02 squared plus negative 2.2 squared, and then we'll get that the ship and the plane are 6.31 kilometers apart, and that is parts A and B of question 39.